Hello and welcome back. We're going to be going back into the Introduction to Machine Learning series, and in this part of the series we're going to be going over specifically what are the three main groups of machine learning algorithms. So as I list off these three groups here, I'm going to go over what questions you might be able to ask with each group, what the data might look like for each group, and then finally we'll go into some examples. Now, as I'm going through these different groups, do keep in mind that each group and some algorithms within each group will all have their own separate videos that I will go more in depth into. So just to firstly label off what the actual groups are, the first group we have is reinforcement learning. The second group of machine learning algorithms is unsupervised. And then the final group of algorithms is supervised machine learning algorithms. So now the question is, what kind of questions do each one of these algorithm groups cover? What are the different questions that they might cover? Well, say if we are looking specifically at reinforcement learning here first, we might think of, okay, say we have a function, we want to, say f of x, we want to minimize or maximize this function in some way. So that could be one thing we might be looking into. Another way of putting this is to say we have some input, some structured input, and we want to find the, quote, best results for some structured input. Now again, this is going to be either minimizing or maximizing it, but you might be going beyond just simple numbers for a function. So, just kind of reiterate what I mean by a function may be as simple as something, say like 3x squared plus 7. It might be something as simple as that for minimizing a function. So in this case, you could just be looking at simple integers or floating point numbers for x, and you want to just minimize f of x in that case, or maximize f of x. The same can be said for here. You might have some input, and you want to just find whatever for your problem best means. And I'll again be going into two examples for reinforcement learning after I'm done explaining both these questions and some data. So now going into the unsupervised section, going with the same thing of asking what questions might be asked, you could have any of the, say, data that is unlabeled. So that's the one thing to note, is that you only have x. You do not have any labels for this unsupervised section. You only have just a data set of data points, no labels associated with them. And you either want the algorithm to tell you something about that data. So in this case, you might be thinking, okay, I have some data here, I don't know what it means, or there's something hidden in here, I know it, or I'm trying to look for something. Algorithm, you tell me about it. So that's one option. Another option you might be having is, I want to condense it. Maybe you have too complex of data, and say images could be a good example of this. And you want to shrink, say you want to go from a either larger image to a smaller image in general, or maybe you want to go from a dense pixel count to a more sparse pixel count in your image. That's something you might be able to do as an example for condensing your data, or in this case, condensing X. And it's not so much condensing the data points of X, but it's condensing the features for each data point. And then finally, moving on to supervised learning, the question you might have for this is to think of, okay, I have the both X and Y. So I have this data set and I have labels associated with each data set. So then the question is, can I predict Y given X? So that's the type of question, that's the question you'll be asking in a supervised algorithm approach. Now, moving on from these questions, we now have, well, what type of data could we be looking at? So I've already hinted a little bit of the data for each of the three groups, but just to go a little bit more in depth, for reinforcement learning, the data would be most likely structured. And by structured, that could mean it could be a graph that you're inputting. It could be a class if you're thinking of, say, class, an object-oriented programming language like Java. You might have classes thrown into this algorithm, and then you're trying to find somehow the best configuration for a class. It might be, say, it could be anything, really. It could be audio, it could be just about anything, as long as it is structured in a way that you can change it, and you're trying to minimize over some function. So that's the main thing that you need to remember, is no matter what the structure of data you're looking at, you're still wanting to minimize over, or maximize, I should say, minimize or maximize some function. So again, structured data also in this case could just be a single integer value or a single floating point value or something else, or it could be a graph where maybe you're trying to minimize the number of edges on the graph, but you're trying to adhere to some function. So that could be something, or again, the object-oriented approach with classes. But that's ultimately what you're looking at in reinforcement learning, is your data is in the form of some structures, and you are trying to minimize or maximize those structures in some given way. And I should write structured data here. And then, as I mentioned, it could be integers, floating point numbers, or possibly graphs or something else. All right, so now moving on to both the supervised and unsupervised algorithms. Both of these approaches, these groups, have the same input. It could be any of the given options that I mentioned in the previous video. So any of the data types from the previous video. And more. Those were just a few examples of data types that you might be running into. But any of those data types from the previous video are options that you could see as both the X for both supervised and unsupervised, but also the Y for the supervised. So these could be for, as I just said, for the X and Y for supervised algorithms. So that's the main thing you want to think about when you're looking at the data types. Reinforcement, most likely some sort of structured data. You might be able to push it down into maybe a single data type. And then for supervised and unsupervised algorithms, it really any data type can be given, pixels or whole images, even audio, text, floating point numbers, anything. So that's the type of data that you could be looking at for each of the 3 different groups of algorithms. Okay, you know what the 3 groups are. I've gone over the questions that you might be able to ask for each group. I've gone over the data for each group. Now, what might some examples for these different groups be? So say if we go over reinforcement learning, what could 2 possible examples for reinforcement learning look? So say in option 1 here, we could be trying to, say you're trying to minimize some function. So if we have some function here, we'll just give a simple, let's say that it looks like this. And then this is slowly coming back up like that. So say you have some function like this. Now the question is, we want to try and maximize, or I'm sorry, you're trying to minimize this function. So in this example, we're trying to minimize f of x here. And this line is f of x. So that would be an example for minimizing or maximizing a function. And this f of x could be anything. In this case, it's whatever this line could be. And for this example, say the minimum would be something like here. That might be the minimum for this function. That would be what your reinforcement learning algorithm would be trying to find. And as a problem with any algorithm, or with any searching algorithm or minimizing maximizing algorithm, it might get stuck at these 2 locations, but that is where you will have to do a little bit of trial and error, and also adapting the algorithm a little bit here and there with the hyperparameters of it to see if you can find an actual minimum like we have here. So that's an example of either minimizing or maximizing a function. But I talked about structured data as being an option. So what could some structured data actually look like? And what could we be trying to do? Well, say let's make a maze here. Very, very crude maze. Maybe we're starting here and we finish here. And it has some paths associated with it. Something like this. Not nearly correct or decent, but, or even a maze at all for that matter. And I'll put another one here. But say this is your maze, so to speak, that you're trying to go through. Maybe this could just be a robot trying to move through a building. Say these could be boxes in place or office equipment in place, maybe printers and desks and whatnot. And you're just trying to get the, say, robot from the start here to your finish here. So this could be a means of structured data where maybe we're trying to minimize the time it takes to go from start to finish. That could be the function, quote unquote function, that you're trying to minimize is the time it takes to go from start to finish. And for the structure of your data, it could be the commands that you might go and give to your robot. So maybe it's, say, a graph where you have nodes in your graph of things that your robot will be doing. So maybe here it might turn right, so it would come out here, turn right first, go some number of steps. So maybe it would go some number of steps, then turn left, and so on. So maybe this could be it. And what you could do is this graph here could be your structured data that you then put into this function or into the robot that you then could maybe simulate in this maze or room or whatever you're trying to simulate. Have it run and get some result out. That could be what you're trying to minimize over. And so you could then be changing this graph. You might change one of these nodes. Maybe this isn't a turn left, but maybe a turn right, or so on. So then that's going to the whole changing scenario or objective of reinforcement learning. And that's going back to the whole idea of reinforcement learning, where you're trying to reinforce good behavior, quote, so to speak, and not reinforce bad behavior. So in this case, say bad behavior for the robot might be turning left here and going all the way into this corner, because that could be a really detrimental move. Maybe there's something here that could destroy the robot or something. That's something you don't want to do. So in this case, you might give the robot negative points if it goes this way. That could be something. And then, so maybe one time the robot does simulate going this way and it reaches this X, you give it some negative points and it changes the behavior based off of those negative points. And subsequently, maybe if it takes a really short amount of time to go to F, then that would give a large number of positive points. So that's where the reinforcement name comes into place. Sort of like if you do reinforcement training for a dog, if you're trying to maybe teach them tricks or teach them something else, maybe to go for walks, you're trying to reinforce them. Maybe if they do the trick properly, you give them a treat. Or if they don't do the trick properly, or don't do the trick at all, they don't get a treat. Something like that could be a good analogy for reinforcement learning. Now moving on from reinforcement learning to unsupervised learning. So in this case, we'll be doing unsupervised. What could be two examples for unsupervised learning? Well, one good example for unsupervised learning is looking at, say you have some retail owner, you own some stores that sell products and whatnot, maybe clothing in this case. And for instance, you might sell 3 different types of clothing, maybe shirts, pants, and shoes, we'll say. So you have a bunch of data on your customers on selling all of the items in your store, and you might want to throw all the data in and see, can you find out anything about your customers that buy any of these 3 articles of clothing? And so let's say your data looks like this on the graph here, where maybe these red points are people that might buy shoes. These points on the graph might be people that buy pants at your stores. And then the green here might be people that buy these shirts at your stores. Now you have this graph, and as a human, you would not be able to see much from this. You wouldn't be able to glean much of any information from this, because in your eyes it would just look like a bunch of maybe black dots, or maybe you could color them in a graph and you wouldn't be able to really see much. But what you can do with unsupervised learning, now remember, unsupervised, there's no labels here, and we can check that you you're not saying like, okay, can we predict how much the customer is spending? You're not trying to predict that. That maybe you have the checkout price for each customer being labels, but you don't have that here. You're just asking, can you get any information from these customers that you have by the products they purchase? And so you might ask the algorithm, okay, I have all this data, cluster it into 3 different clusters. So maybe the red here clusters like this, and then you might have a blue cluster like this, and then a green cluster like this. So now you have these 3 different clusters of your customer data. And so now you could be able maybe either take the data and maybe print it out to some Excel sheet and do some analysis from there, or maybe you're comparing the data. So maybe the X here is the item that a person bought, and maybe the Y is some other data point, and you're just trying to compare X and Y and just see, in this case, well, the red cluster has low Y values, the green cluster has also low Y, and so on. That might be something you could be looking for. But that's what unsupervised learning could do. You just have a bunch of data, you want to ask a question about your data, and it could answer that question for you. Now, moving on to another example from unsupervised, and that could be what would be considered, what the term is called, of dimensionality reduction. So I can write that over here real quick. Dimensionality reduction. That is the name for what you're doing for this example that I'm going to be mentioning here in a second. For this example, you might be, say you have some really high resolution pictures that you might be looking at. So just to give a very crudely drawn picture here, where each one of these squares may be a single pixel in the picture. So you might have this picture here. And again, we could go back to a previous example that we've talked about, such as the MNIST data set. So maybe this could be a 28 by 28 image for looking at handwritten digits. That might be something you could be looking at. And in this case, you might want to reduce these pixels for some reason, but still, you want to reduce the number of pixels in the image, but you still want to maintain the original image quality, or not so much the quality, but still be able to tell what the original image is. So maybe if this original image was some number 5, you still, after the reduction, would still want, maybe it might look a little funky, but you still want to be able to tell that the output is still a number 5. So in this, you might be doing in this case is, you might be, say, reducing the image to whatever, this could be a 3 by 3, which would be a very large reduction in this case. But that might be what you could reduce it to. So this is what dimensionality reduction is, and this is an example for unsupervised learning. You're taking the data, you have no labels on it, in this case, you're just changing the data, reducing the number of features you have, because you want to remember each image here is a single data point in your X data set, and you're just shrinking the number of features for each data point. So you're going from a 28 by 28 image down to a 3 by 3. So you're reducing your number of features to that amount. So these are two examples that you might have for unsupervised learning. And finally, we can move on to supervised learning. So we just talked about unsupervised. So the next part could be, what about supervised learning? What could be two examples for supervised learning? So if we look at, say, again, for supervised learning, going back to what we've talked about earlier in the video, we have an X and a Y. So our data and our labels. This is what we need to have for supervised learning. So what could be two examples here? Well, say, for example, our X is some student data. Maybe it's test scores in a specific class, or overall test grades in all of the students' classes. Maybe it's some standardized tests, whatever you can think of. This is what X could be. So each data point here in this X data set would be a single student, and then the number of features for each student could be your data. So say if a student takes 7 classes, they would have 7 features. They would have 7 features because there's 7 grades for each of those 7 classes. And say we have this Y being a 0 or 1 of whether the student was successful after they left school. So 0 meaning the student was not successful, however you define successful. This is just an example, but in this case, however you would define successful for a student, 0 could be they were not successful, 1 being they are successful. So these would be what you would have. And then your algorithm would it would train on your X and Y, and it would train to see, okay, given this X data set with these students and their grades, can I predict, easily predict on Y, a yes or no, 1 or 0 result, was a student successful? So after you're done training, you can then take just one random student and you could pass in that student's information and get an output to say whether they might be successful or not. So you might have one single X value passed into the algorithm, and then the output could be some prediction after it's done testing. So you first do your training, and then you can do your testing and maybe real world example if you are happy with your results. So you could then just give in a single student data point into the algorithm, and the algorithm would output a yes or no prediction. And maybe you might want to use this prediction to say, okay, if you get a 0, you can then say, well, the student's not doing good in this course. Maybe that's the problem. Let's go and try and maybe give them some tutoring in this course, or see if they need help in this course and help them further along. Or even after this case, you might say, okay, there's an obvious correlation for students that do not pass versus students that are not successful versus students that are successful, because maybe the algorithm performs very well. Maybe you might then perform an unsupervised learning approach and try and maybe cluster unsupervised versus supervised, or unsuccessful versus successful, and see if there's a difference that you can see from the data from those clusters. So in that case, you'd be putting multiple algorithms together to then ultimately try and solve the case of, can you predict if a student will not be successful, and then if not, how can you improve their likelihood of being successful. So this could be one example. Now for another example, this is a little more outlandish, but a lot of companies are trying to also actually solve this problem. And that could be, say you're a stock trader and you want to predict whether some stock is going to be low or high. So say, I don't know, you're looking at some company X, we'll just say company X in this case, and you want to see it's their stock price. So you look over maybe the past year of data and you see their stock price looking something like this. So maybe that's their stock price that they might have. And looking at this imaginary company X here, we want to predict, say, what would be after this? What could be, would the next part be going down, or would the next part be going up? Which one is correct? Because then here, this might tell us, do we want to, say, go down here and buy more stock, or do we want to wait until we go up top here and sell? So this could be a good example of another good example of supervised learning, where you might have this X here being, say, time. Maybe it's a day, maybe it's an hour, minute, second, maybe even, depending on how fine-grained you can get it. And then this would be, the Y here would be equal to the price. So that would be your input. Your X would be a time, your Y would be a price, and you would say the next 15 days or 15 hours, you would take that time, put it into the algorithm, and get out these prices. You would get out hopefully either a green, or you would get out this red line, or maybe there'll be something in the middle. You don't know, but that's what your algorithm could try to predict. So these are two easy examples of supervised learning algorithms. So with all of this said and done, we have now gone over the three main groups of the machine learning algorithms. So reinforcement, supervised, and unsupervised. I've gone over what data types each group might be associated with, what the questions you would want to ask for each group of machine learning, and then also two examples for each group. So in the next few videos, as I mentioned, we'll go more into depth of each group of machine learning. So the next video might either be a more in-depth look at reinforcement learning or supervised or unsupervised learning. And then after those, I'll go into different algorithms that you'll see in each group of, in each one of these three groups. So maybe I might go into a genetic algorithm, which is part of the reinforcement learning. I could go into that and say why it's reinforcement learning and what you could do with it and so on. So now you should be able to understand what the three groups are, what you might be able to do with them. So now the next question you might want to ask yourself is, maybe you should try and look at some problems and see what group those problems fall into. Is it a structured piece of data that you're trying to minimize or maximize? Is it a data set with labels that you're trying to predict those labels for? Or is it just a data set that you're trying to ask questions on? And with that, I will see you in the next video.